Hello friends, myself Varmavasti. And on this evening, in this video, I'm sharing my views on anti-friction bearing. Uh, you will see that anti-friction bearing on the table sides. The content I want to show you the instruction, function of the bearing, classification, and method of application. These of power transmissions are belt pulley system, gears. Basically, gear belt pulley system are mounted on the shaft. These shafts basically support on the bearings. These bearings might be anti-friction bearing, or you may say rolling contact bearing, or it may be journal bearing, or you may say sliding contact bearing. In this video, I'm sharing my thoughts on the anti-friction bearing, or you may say roller or ball bearing. Now first come to the introduction. A bearing is a device to permit constrained relative motion between two parts. Why I'm saying this word constrained? Because the arrow I am showing here, the shafts insert in this cage while housing covers this outer cage. It means that shaft is only allowed to be in rotational motion in this particular inner cage. It means that shaft is constrained to be in relative motion with respect to that inner cage in rotary manner, not in linear manner. So linear motion is constrained. That's why a constraint term is appeared here. You may also see that when there is a relative motion between two machine parts, one of which supports the other, the supporting member is called bearing. It needs a good support to ensure stability and frictionless rotation. Basically, function of the bearing is to minimize frictional resistance between shafts and the housing. Maybe you may confused about the housing. I want to see the exactly photograph of the housing. This says housing. Housing the fixed part in which bearing is mounted. Shaft is inserted through this inner cage while housing supports bearing and shaft. So basically a shaft maybe have more than one, two supports. We may also see in figure 1 that shaft, if supported on a bearing, may be loaded by gears or belt pulley system or chain drive system. Bearing may have axial or radial load or combination of both. Suppose that if we mounted a spur gear on this particular shaft, then weight of shaft which is acting downward as well as the tangential force offered by the gear is treated as radial forces as it acts on the shaft in radial direction. If a radial force is acted on the shaft, the bearing offers reaction in radial manner. Suppose if the gear is in case of helical gear, the tangential component as well as radial component along with a axial component. So the gear, belt pulley system or chain drive system combinedly load the bearing in terms of reaction as an axial, radial or combination of both. Finally, a bearing may be selected as in case of load as radial load, axial load or combination of both. Now, if we see the terminology, or you may say general classification of the bearing, or you may say exactly cut sectional view of a bearing, we may see that it is called outer edge, which is fixed in the housing, while this is inner cage, which is fixed with the shaft. Cage have negative tolerance so that relative motion between inner cage and shaft is not permitted. The inner cage is attached with separator or you may say retainer. When the inner cage is rotated with respect to outer race with shaft, these radial element or you may say roller element or you may say ball elements rotates like that. Inner cage is rotating here, or you may say inner race is rotating here, while these pulling elements roll about x, y, z axes. It means that there is no constraint of rotary motion for this ball, while there is constraint of linear motion of this ball. These outer edges, or you may say outer race, is fixed with housings, while these inner races are attached with the shaft. It means when a shaft is supported, then at least there are two housing with bearing systems. Detailed nomenclature, we may see that well when we refer for any design data book, design data handbook, we have following parameters like outside diameter of the bearing. It means that it should be fixed, it should be prefixed that for a given housing, a particular type of bearing can be attached only. Both, or you may say outer diameter of shaft. This shows that up to which maximum limit a shaft can be inserted in a particular bearing. The shaft design depends on various parameters like material of the shaft, load offered on the shaft. This load may be bending, maybe weight of the power transmission device, torsion. So shaft is designed basically on the equivalent bending moment and twisting moment formula. When shaft diameter is designed, on the basis of that, a bearing can be selected. Now next, as these rolling elements are rotating with respect to this outer edge, proper sealing is incorporated. This blue cover is treated as sealing so that anti-friction element like grease and oil cannot be spilled out from the bearing, and which offer these rolling element to be less friction. Selection: how a bearing can be selected. As we see, I have said in earlier slide that there are two types of load, radial and axial or combination of both. So load is the major criteria for selection. Second one is shaft alignment. This shaft is perfectly aligned. There is no need of any special type of bearing. Else, a special type of bearing can be incorporated. We will see it later. Next one is maximum permissible speed, means RPM, revolutions per minute, which is offered through power transmission device, or means from which for which power transmission device the shaft is attached. It may be generator, it may be electrical motor, etc. Third one is rating and noise. Ball or roller bearing is common type of rolling element bearing. In ball bearing, the point contact is between outer edge and inner edge, while in case of roller bearing, there is line contact. Both supports the radial and axial load. Further, the classification of the bearing depend on types of load and nature of load. By these two parameters, there are following type of bearings like deep groove ball bearing, double deep groove, angular contact, cylindrical roller, lap lining, paper roller, spherical roller, and thrust ball bearing. Details of these bearings are shown as there. Like if these type of bearings are incorporated in the system, this type of load with given rotation or RPM selection procedures can be achieved. Like in case of deep groove ball bearing, it can offer or it can reduce both radial as well as axial load with high RPM. While in case of angular contact bearing, it can offer radial load axle load, but axle load is only on one direction. Same as cylindrical roller bearing, it also offers both radial and axial load, but load carrying capacity of this particular bearing is greater than the true ball bearing. As we have seen that the rolling element is of two nature. In this case of in this case, rolling element is ball, while in case of this bearing, rolling element is the roller. Obvious is obvious. In case of ball bearing, contact is like point. In case of this bearing, contact is like line. If point contact is there, means that stress generated with respect to particular load is higher. While in case of roller bearing, stress generated with respect to particular load is lower. It means that load carrying capacity of roller bearing is much higher as compared to further needle bearing. It's only incorporated for the radial loads. Taper bearing for both. Obvious, there is obvious in taper bearing and roller bearing. Both in both type of bearing, element is roller, but in taper bearing, roller is inclined with respect to horizontal axis, or you may say longitudinal axis of a shaft system. Load carrying capacity of taper roller bearing is exactly same as roller bearing, but it can resist axial force in a better way as compared to roller bearing. Next one is self-aligning. Uh, in case of design criteria, we have seen that there is a criteria of shaft alignment. If in case if shaft is misaligned or maybe eccentric due to heavy load, this type of bearing in this case will be incorporated. Next one is thrust ball bearing. Thrust ball bearing is mounted vertically with respect to shaft system, which is only designed to sustain radial loads. Now next is bearing specification. When we go to the market to purchase any bearing, we have to told the distributor by their code. The biggest distributor, you may say manufacturer of the bearing is SKF. SKF bearing available in the market with a given code number. Suppose that we may take an example 6221. Bus number 6 is justified for the V group, same as 2, 3, 30, 31, 32 for different type of bearings. Next number is 2. 2 is for light series, same as for 0, 3 and 4 for different type of loading systems or conditions. And last two digits for the board average. It means that if we selected 6221, it means that the bearing will be a deep groove ball bearing which is designed or which can be selected for a light load with a bore diameter for the 21 onwards, as 21 is not seen here. But if we see 6203, if I have choose 6203, it means that 03 for 17 diameter for the shaft. Design parameters, on which parameters bearing can be selected and designed. Number one is type of load. We have seen type of load may be radial, axial, or combination. Static load carrying capacity, dynamic load carrying capacity, equivalent static or dynamic load, life, load factor, and reliability. There are 7 parameters on the basis of which a bearing can be designed or selected. Bearing are selected from the catalogs for commercial point of view, and for educational point of view, it can be selected from the design data handbook. What the parameters we should know when we are going to select any bearing? Parameters are bearing load, the exact magnitude and direction, being magnitude wise the value and direction wise either load is axial or radial. The second one is bearing life and reliability. Bearing speed. Space limitation means the space in which bearing is to be mounted, or you may say the space in the housing. And last one is accuracy. Methodology to solve the problems. To define all these parameters, firstly I want to go for the design parameters. They are the parameters. One by one, I'm telling you all parameters all about. First one is static load carrying capacity. Static load carrying capacity is defined as static radial load in case of radial bearing or axial load in case of thrust or roller bearing, which corresponds to a total permanent deformation of the ball or roller or in race, maybe in inner or outer race, at the most heavily stressed contact equal to 0.001 times of the ball or diameter. Means that if the bearing is mounted here, when the system is not running, the rolling element, which is exactly below overall elements, is treated is to be heavily stressed as the weight of fear, the radial load of fear is acting continuously. At this stress level, the stress generated is type contact stress, is of contact type of stress. At this stress, at this stress, strain will develop and deformation will occur. The deformation will occur, it should not be greater than 0.01 times of the bottom or roller diameter. If it is greater than this value, bearing is assumed to be paid. It means that if we select any bearing, firstly it is checked on standby condition, stand-off condition. We mount the bearing and check that if whether this limit is exceed or not. If limit is exceed, we replace the bearing and mount the next one of greater load carrying capacity. Life. Next parameter. There is a typical definition of life in case of bearings. In manufacturer catalog, or you may say in design catalog, life is predicted in many ways. To standardize the system, manufacturers offers a view that life of bearing can be predicted on the basis of their reliability, as one by one bearing can't be checked that whether its diameter exceeds from the 0.001 limit or not. So it is concluded that the rated life of group of apparently identical ball or bearing is defined as the number of revolutions or arcs at some given constant speed that 90% of the group of bearing will complete or exceed before the first evidence of fatigue develops. Only 10% of the group of bearing will fail due to fatigue, as this 10% is a key criteria for the design. That rated life is treated as L10 life. In this case, we assume our manufacturer catalog suggests us the liability will be taken as 90%, or you may say as a value 0.9. On different reliability systems, the type of life will be changed. Suppose that if we ask manufacturers to provide us a bearing of less reliability, like 50%, then life will be treated as L50. If we ask manufacturer for the greater reliability, like 99%, then life will be treated as L01. The term minimum life is also used to denote the rated life. To standardize system, manufacturers offers in their catalog either rated or minimum life. Or you may say L10 life. It has been found that the life which 50% of the root bearing will complete or exceed is approximately 5 times the life which 90% of the bearing will complete or exceed. It is general criteria that if we purchase any object, or you may see, I am taking some example, if we purchase a TV, television, we just not switched on it, we just not use it, the liability will be 100%. But when we use it when we use it while daily basis, the reliability of the system will be decreased. In the same way, if the reliability of system or engineering is lesser, life will be higher. While reliability is higher, life will be less. The next one is dynamic load capacity. The dynamic load rating. The basic dynamic load rating is defined as the constant stationary radial load in case of radial ball bearing or constant axial load in case of thrust bearing, which a group of apparently identical bearings with stationary outer ring can endure for a rated life for 1 million revolutions. This is a tedious and tough definition, but in the easy way, we may assume that, or we may state that for 1 million revolution of particular bearing, same type of bearing, the load either radial or axial is acted on it is termed as dynamic load capacity. Next one is load factor. Load factor K is a constant factor or value that depends on which type of system is mounted on the shaft. If spur gear is mounted, the value of factor will be changed, will be separate. If we mounted helical gear, belt pulley system, chain drive system, the value of factor K will be different. Next term is reliability. As manufacturers suggest us that in their catalog they have opted only 90% reliability criteria, we fix our value as 0.9 for reliability. If we have to convert this reliability term for the lesser or higher value, the selection criteria may be different. Now, the methodology to solve the problems for the students for selection of bearings, as P either given or can be calculated for a given bearing in terms of radial load or axial load. P can be calculated as x FR plus y FA, where x is a radial load factor and y is axial load factor, while FR and FA are the magnitudes of radial and axial loads. From the design data book, for given system, we can easily select a value of x and y by putting the value of x and y with FR and FA. We easily calculate P, which is a effective load on the bearing system. By multiplying P with a load factor, we can calculate or we can measure the effective load on the system or in the bearing. Next, L10 is equal to C upon P to the power n. That formula is justified for the selection of the bearing. If life of bearing is given for given load, we can easily calculate the value of C, which is the dynamic load carrying capacity. For the given bearing, if dynamic load carrying capacity of the bearing is given for given load, we can easily calculate the prediction of life. By this formula, we can easily calculate the life or dynamic load carrying capacity of the bearing. In manufacturer catalog or design data book, the value of C, C naught is given for different type of bearing. On the basis of that data, we may easily calculate predicted life for the given bearing. After selection of bearing, we can check the dimensional accuracy like width, corner radius, shoulder fitment, that whether this bearing will be mounted in shaft or housing in a proper way. Okay, it's all about the selection of anti-friction bearing, or you may say roller bearing. Thank you.